Hello, we are Ion Storage Systems based in College Park, Maryland. Traditional lithium-ion wasn't the first or best battery technology, but it was the easiest to commercialize almost 4 decades ago when it was invented, and it has a major flaw. It was built 40 years ago on an unstable platform with unstable chemicals, and 40 years later today, it still is. The industry has had a huge outcry for more runtime and also better safety for their devices. Finally, a better option from Ion Storage Systems is here, and it's 100% safe with no trade-offs for performance or safety. The batteries we have and the batteries we want. At Ion Storage Systems, we build batteries that don't have any trade-offs for performance over safety. That means your devices will work for longer and are completely non-flammable and not prone to thermal runaway. Our solid-state cells don't gas or dimensionally change over time. That means that while developing a device around our battery, you don't have to include an industry-standard swell budget, or in other words, wasted space allowing the battery to grow and swell over time. This will allow designers to create smaller and more compact products. Finally, and very importantly, we want batteries that don't need to be cooled or air-conditioned at high temperatures. Our battery works from below room temperatures to very high temperatures. For example, when using or leaving a device in the sun, it will likely shut off due to overheating to protect itself. In larger applications, like energy storage, it is common and necessary to use air conditioning to keep the batteries cool, resulting in a large round-trip energy efficiency loss. Our extreme all-purpose hybrid battery meets the most demanding customer requirements for all 4 main consumer segments, and our 4-phased approach for quick market entry allows us to scale our technology as our business grows in parallel, minimizing risk. Delivering products into the hands of our customers as our capabilities grow while meeting their needs ensures a smooth introduction of our product in each segment. The main line of combustion defense in a traditional lithium-ion battery is a flimsy micron-thin layer of plastic separator between the anode and cathode. The unique performance advantages of our technology come from our patented multi-layer ceramic electrolyte design, which replaces this layer in flammable liquid used in lithium-ion to separate the cathode and anode. This is what makes our battery safe and capable of high-temperature operation. This ceramic is stable with the best electrodes available, including lithium metal, which generates extremely high energy density. Our batteries are tough, able to operate under a wide temperature range. Air conditioning is not needed to keep our batteries cool, eliminating parasitic losses from complex and diminishing return systems normally put in place to support traditional lithium-ion. The chart shown displays our Generation 1 technology, which will be available for customer evaluation later this year. This generation has an energy density of 265 watt-hours per kilogram, with an operating temperature range of -10 degrees C to +90, with similar C rates to traditional lithium-ion batteries while remaining non-flammable. It is important to note that while traditional lithium-ion has lately seen smaller incremental improvements in its 40-year life, our Generation 1 battery, which is already competitive, is only the beginning. We are really excited by our Generation 2 technology, which uses the same exact chemistry as before, but with a modified structure which reduces space and offers a 20% improvement in energy density, as traditional battery suppliers struggle to make single-digit improvements in the same time frame. In 2020, we have transformed from a university spin-off to a commercial, customer-focused company. In just a few months, we have scaled our technology to 4x the original footprint and transitioned from an R&D style coin cell to an industry-standard pouch battery. Next year, we plan to scale our battery again with a 7x footprint increase, as well as stacking multiple electrode pairs in one pouch or prismatic cell. In 2020, we're focused on optimizing our manufacturing processes and shipping batteries to customers for evaluation. In 2021 and beyond, we will begin scaling up our manufacturing to 3 megawatt-hours. 3 megawatt-hours is roughly 250,000 cell phone-sized batteries per year. I'd like to introduce our leadership team. Dr. Eric Waxman, co-founder of Ion Storage Systems, has over 30 years experience in the industry, initially developing our technology at the University of Maryland and continuing to improve and enhance its capabilities for further generations. Mark Fields, partner at Alsop Louis, a Bay Area venture capital firm, brings a host of commercialization knowledge and strategic advantages, helping transition Ion to a customer-focused company. Ricky Hanna, CEO of Ion Storage Systems, with 22 years of experience in the battery industry. His most recent role as Executive Director of Battery Operations at Apple's had him responsible for manufacturing batteries for all of Apple's consumer electronic devices. He was tasked with shepherding the technology from a lab in Cupertino through scaling it up to 1 million batteries per day in a very short period of time. Greg Hitz, our CTO and co-founder, leads the product development team as we bring this exciting product to market. Joining the team at its earliest stages at UMD, Greg has led the company from its transition from research and development to product commercialization. Finally, I'd like to introduce Dr. Charles Lewinson. He brings over 20 years of experience in the ceramics industry and is focused on the manufacturing scale-up. As we engage with market-leading customers in all segments and industry thought leaders, we find that they are as excited as we are in the potential of our extreme all-purpose hybrid. See what they have to say about us.